so we're recording now. If you're watching this video, I started recording about 12 minutes early, so you can skip ahead until about, skip ahead 12 minutes if you want. But I just wanted to go ahead and start recording, just in case somebody comes in and asks any questions that would benefit everybody else. So there we go. Yeah. Set up.
I'm gonna skip that sound.
And it's Carla, right?
Yeah,
Yeah, got it.
I'm clumsy.
Yeah.
And forgetful.
I'm becoming more forgetful. I used to not be, but it's usually in his words I forget. Like I'll be having a conversation with my wife and just stop and think, and it's a real basic word, nothing complicated. It scares me.
That's why I can listen to music and study, because my mind doesn't stop.
Me too.
So if I have to have a lot of distractions for me to concentrate.
Yeah, I'm like that too. I always have music going on, or like when I'm working from home, if it's not music, I'll have some show on that I'm not really paying attention to, but it's there. It's in the background.
I have to, because I don't know, I'm like a knowledge person, so that's, and I observe stuff. So like this is my downtime. I'll go out here and get my stuff so I can come in here and pay attention.
Right.
To this because you're new. I don't know your biology, and you talk about labs. And I was like, yeah, I'm gonna have to pay attention. But that's why I went here to study. Now, got them. Went through chapter 1. I got the definitions and stuff because I feel like if I learned the vocabulary, I'll be able to keep up with what you're saying. You know what I mean?
Yeah.
So that's why I'm already. I already got my reservation at the Canal Library from 9 to 12. I ain't playing with y'all.
That's great. That is so great.
But yeah, I will always reach out if I have a misunderstanding or something like that because I am usually hard on myself, but because I'm my worst critic.
Right.
But I like critique. I'm trying to use that word this year. Critique, not criticism.
Right.
But yeah. But no, thank you so much though. Because she appreciated it. I said, girl, get that extra credit. Look for these keywords in his sentence. What you say? To claim your extra credit or anything like that. I said, yeah, start from there.
Yep.
Read that paragraph.
That's right. Read it carefully.
Yeah. I keep doing this. See what I mean? The whole purpose was me to go outside. Listen to music.
Yeah, forgetful.
Morning.
Morning. How are you?
Good. How about yourself?
Good. It's glad to be here. This weather. Nice to make it. Let's see. All right. This is a multiple choice quiz for me with 20 choices. I'm going to try to guess who you are, so don't tell me, please. I'm going to try my best to guess. Let's see. Of course. No. Maybe. This is tough. So many choices. Is it Walter?
Yes, sir.
Hey! Walter Hughes.
Yes, sir.
All right. Just so you know, I've already started recording. You know, we're streaming and recording. So, you know, if you have any personal questions to ask, just know that you're being recorded. Morning.
Morning.
Morning. Yep, this is us. Yeah. For those of you who just came in, just let you know we are already recording. So that usually shouldn't matter, but who knows? Sometimes you don't want to say something that's being recorded. If you were to ask me questions on how to dispose of a body, for example, you probably don't want that being recorded. I wouldn't. Anyway, we've got, oh man, we only have 2 minutes. I was going to try to guess who everybody is. But I don't know. I might. hopefully more people show up. So don't anybody tell me yet. I'm gonna go with Christopher. No. All right. In this case, I won't guess for you. What's your last name? It's all right. Okay. Let me see. I'm trying to do more guessing. Actually, shoot. This time, 1 minute left. So I'm gonna go ahead and just do attendance as usual. Bangura. Last name Bangura. Last name Canty. No Canty. Last name Casbolt. Is it Casbolt or Casebolt? Casebolt. I'll try to don't hesitate to correct me if I mispronounce your name. I'll do the same. But just know again, I wouldn't be offended if you mispronounce my name. All right. Last name Chiampanella? No. All right. Covington Griggs. Not here. DeVere. Where is it? Dow. Dow. Hughes is here. Lebdy. Lytle is here. Mankins. Mathis. Mathis is here. You wear a WBSU gear by any chance?
Me?
Yeah.
Yeah.
You are? All right. You get a little extra credit. I'll explain that in a second. Price. Price is not here. Raines is here in the back. Reed. Reed is not here. Renee. I think she's the one. No, she won't be here until next week. Ross. No Ross. Thompson. Thompson is here. You wear WBSU gear. I'll explain that in a second. Withrow. No Withrow. And then Yindui. All right. So, I know I didn't call your name. If you don't mind, send me an email or stay after class to remind me that you're here. I might need to add you to my roster. Did I forget anybody else that's in person? Okay. So let me look really quickly to see who's online. For those of you who are online, looks like we have, come on, my cursor. There we go. Looks like online we've got Bangura and DeVere, so we're still missing quite a few people. But anyway, if you're online, throughout this lecture, I'm going to give attendance words. So you're going at the end, sometime before 9 a.m., you need to send me an email that has all the attendance words. So don't send them each time I say one. Wait until the lecture is over, and then send me those words. And for the rest of you, since you're already here, you already get the 2 points of extra credit. You don't have to do that, but you can. So if you send me those attendance words to prove that you were paying attention and not just sitting here and edged out, then you'll get even more extra credit. And speaking of which, like I said, 2 of you got extra credit for wearing WBSU gear. I forgot to tell you that on Monday. But every Wednesday, I call it WBSU Wednesday. I'm trying to make it a thing. So if you wear WBSU gear on Wednesdays, you'll get a little bit of extra credit. Same thing with red on Fridays, but I'll explain that on Friday. So that's pretty much it for attendance. We already talked about attendance. And again, attendance is mandatory. You get extra credit for attending. You get 2 points per meeting if you're physically here. And you get 1 point per meeting if you join us virtually or watch the video. What else for attendance? Yeah, and again, obviously, if you can't make it in person, join us online or watch the video afterwards. I guess that's it for attendance. Oh yeah, and then again, finally, to remind you, attendance is a lot less loosey-goosey when it comes to lab. You have to be at the lab every Wednesday at 10 a.m. It's not like this. You have to be there. There's not, you can't watch a recording or join us online. You have to physically be in this room at 10 a.m. every Wednesday, starting next Wednesday, to do the lab. And if you miss it, just talk to me. We'll cross that bridge when we get there. All right, speaking of lab, you have a due date. Your pre-lab is due this Friday, so I'm going to show you how to find it. At least in theory, if I can navigate this computer. While I'm pulling that up, does anybody have any questions? Okay?
I have a question.
Yes.
We got a lab today, right?
No.
Oh, no?
Normally we have them every Wednesday.
Yeah.
This week, since it's the first week, we don't have it. Great question. So let me show you where to find your pre-lab. You're gonna go over here in My Online, go to Lab 1, in this case. So next week, you're gonna do Lab 2, but you go over here, you click this link right here, and it brings you to the master copy. So this is the master copy of the document. You don't have access to the master copy. You cannot edit it, so you have to make yourself a copy. Everything I'm about to tell you is right here. So if you forget everything I said, that's okay. Here's the instructions, and they're at the top of every single file. So if you forget, you can click it. Before I get started, the first word for attendance is graphing. Graphing is the first word for attendance. So again, for those of you online, you have to send me the whole list of words when we're done with lecture, sometime after lecture or before 9 a.m. Anyway, again, this is what's due on Friday. You open the master copy, you go over here to File, you go over here to Make a Copy, you click that. You can name it whatever you want, because once you make a copy, it's going to be your copy. It doesn't matter what you name it. I don't care. I'll never see the name of it. So anyway, you'll do that. The question was, what's the word? It's graphing, I-N-G. Good question. Anyway, when you make yourself a copy, I highly suggest doing this. Click this box right here if it gives you the option, copy, comments, and suggestions, and then just hit make yourself a copy, and then boom, that's your copy. Does that make sense to everybody? That's how you make yourself a copy. You can do everything online. I do this on purpose. The reason I do this is because, oops, excuse me, let me out of here. The reason I do this is because all your work will be online. You can't lose it. So if you, let's say today, what you should do, you open this up, you start reading it because you know it's due on Friday. Maybe you answer a couple questions, and then your house blows up and you're with your laptop with it. So now you've lost your computer, right? No big deal. Just sign into Google, to your Google WVSU email account, and then you're signed into Google, and you can go to your Google Drive, and there's all your work. So anyway, there it is. Here's all you have to do. I'll go into more detail if you need it later. This is not lab, so I just want to show you. You're just going to need to read through this lab, read through the lab syllabus. It's going to be long at first because this is the first lab. Read through all this information, read about laboratory safety, and then finally when you get to the graphing part, this is the part about the actual lab, the experiment that we're going to do next week. Read the introduction, watch this short 8-minute video, read this thing about graphing, read this thing about hypothesis testing, and then where is it at? Where is it at? Where is it at? Finally, this is what you get to. And you have to do this every week. Every Friday, you'll have pre-lab questions due. So here's your pre-lab questions. Read about it and just answer the questions. And your answers should all come from the introduction, because the questions are just basically proving that you read the introduction. Does that make sense?
Is there a time limit on this too? Friday?
Yes. Just as long as you turn it in by Friday, you're good. Yeah. So yeah, make sure you do that. And even though I'm saying you do it and you're supposed to do it on your own, doesn't mean you have to do it on your own. So if you're looking at this on Thursday and you're working on it and you need help, let me know. We can meet online. I can help you. So yes, that needs to be done by Friday. Fill out the questions. But again, let me reiterate, the answers need to come from your introduction because it proves that you read the introduction. So don't look up any answers. Obviously, some of these questions you can look up and find an answer, but I don't want the internet's answer. I want the answer that's in this document that shows that you read and understood the document. Does that make sense? All right. When you're done with it and you're ready for me to grade it, and again, all these instructions I'm giving you are in this top link right here. So everything I'm telling you, you have access to. When you're done with it and ready for me to grade it, go up here to this top right where it has the little plus button, and you're going to share it with me. Of course, this is my document, so my name's already on there. But just start typing my name, and it'll show up, and you just share it with me that way. So are there any questions? All right, so again, this is due on Friday. This is one of those things I'm not very lenient with because I've had a lot of experience with this. And people who aren't prepared for lab, screw lab up for everybody. So this has to be turned in by Friday because that gives me, on the weekend if I decide to work, but more importantly on Monday when I get to work, I can start grading these and making sure that you're ready to come to lab on Wednesday. That makes sense. It's imperative that you do this. It's only worth 5 points. So point-wise, it's not worth much. But if you don't do it in time, then you can't come to lab, in which point you'll lose all those 20, in which case you'll lose all those 20 points. So you can't come to lab if you haven't done the pre-lab. You good? All right. That's just one of the very few things that I'm picky with. Yeah. pre-labs, and what's the other one? Picking good sources when you write your papers. All right, so are there any questions about lab? All right, let's back out of here then. We are done talking about that. Let me pull this slideshow back up. While I'm doing that, I want to let somebody know, because I was talking to a student, I think from another section, who was talking about how overwhelming some of this is, and I understand that, so I want to acknowledge that it's overwhelming, but I want to tell you, and I don't know why I just thought about this today, because I've been doing this for so many years, but in a way, this is a little bit, the first week of class is a little bit like boot camp. Obviously, none of you have been to boot camp for military, right? You have? Which one? Air Force? Where is that, Colorado, or is that just Texas? Texas, okay. Well, so you're a little bit familiar with this, and the rest of you can probably imagine. So in some ways, boot camp is the hardest part of your military career. In some ways, in other ways it isn't. But the point of boot camp is to get you ready. Like, I only have this short amount of time to get you ready for your entire career, right? Teach you, in your case, how to be an airman. So they're squeezing a lot of information in a short amount of time. That's the first week of class, right? In some ways, this is the hardest week of class because I'm trying to get you ready, get you all the tools you need to be able to succeed in this class. So I'm just giving you all this information, all these documents to read. But after the first week, things are really going to level out. Should be a little bit easier in some ways. Of course, the course material might be a little bit harder as we move forward, but the class itself, the administration of the class should be a little bit easier. So any questions about attendance or lab? If you came in late and there wasn't just one of you, make sure you either get with me about what you just missed or watch the video and I post it later today. And also, if you came in late, make sure you email me and say, hey, I came in late, so I can mark you as present. Late, but present. All right, other reminders. Read the announcements. So if you go to WBSU Online, you'll see that I posted announcements. You should get an automatic email. You need to read those. Once you carefully read them, you'll know that I know if you've read them, right? So for those of you who have read them, you know what I'm talking about, right? So read those announcements. I have a way of knowing if you read them or not. Read the syllabus. That's your other assignment that I've already given you. Once again, just like the announcements, I kind of have a way of knowing if you read it or not. Read chapter 1, because that's where we're about to start today. Yay. I don't have a way of knowing if you read that or not. That's on you. And then finally, again, like I said, you really should start independent work. I could go on and give you ideas and explain how to write independent work, but the best thing for you to do is just write something, turn it in. I can say, yep, next time do this different, right? So start trial and error, start turning things in. And again, a full page paper is usually worth 10 points per page. And for now, it's worth 20 points per page because I'm trying to incentivize you this week, this first week, to start turning stuff in. And to remind you to turn stuff in, you just go to Google Docs, write your document, write it there in Google Docs, and then share it with me. The same way I just showed you how to share a lab with a pre-lab, that's what you're going to do with independent work. Whew. So any questions about announcements or reminders before we jump into chapter 1? Okay, the next word for attendance will be clock. Since there's one right there, right? See that clock? That's the next word for attendance. And again, if you're online, after we finish this lecture and sometime before 9 a.m., you have to send me those words to get to be counted as present. And the rest of you who are here, you can send me those words to add to your extra credit that you already did.
We just email it straight to you?
Yep, just email it straight to me. Good question. And if you want to, it would help if you, like in the section, put like the date, and attendance, extra credit, something like that. But you don't have to. I'll figure it out. Anyway, let's jump into it. All right, let me tell you this too before I jump into this. So this, I think you guys are the second or third semester where we're using this new textbook. For me, it's new. I used to use a different textbook, but I recently switched over to this new one, new to me, because it's free and online, so I think it's better for that reason. But in some ways, the old textbook is better. So my PowerPoints are, even though they're based on the new textbook, I have saved some stuff from the old textbook, and I'll explain that when we get to it. That way, when I'm going through the PowerPoint and you read the chapter, you're like, wait, that doesn't mix, or that doesn't match. So I'll explain when and why that is when the time comes. So here we go. For those of you who haven't been here before, my name is Vasilios Dianelos. This is Bio 101. You can call me Mr. B, Professor D, I don't care, whatever, as long as it makes sense. Let's get moving into it. So this is from your old textbook, but I like that your old textbook did this because they always started the chapter with a set of pictures And that's kind of like a little bit like a guessing game. Like, hey, why does this chapter matter in your everyday life? Like, obviously, this matters for this class. This is why it's in here. But why does it matter for your everyday life or for society in general? So let's go ahead and play the game a little bit. It's a little bit hard to see. But can anybody guess what this thing is? It's a little bit hard, but any guesses?
Robot.
It is indeed a robot, yes.
Moon robot.
It is on a different body, yep.
It's a
Close
Mars
enough.
rover.
Mars rover, yeah, exactly. And what your old textbook, what it was getting at here is that thing is looking for a lot of stuff. And one of the things it was looking for is water. Because as you're going to learn throughout the semester, without water, as far as we know, life can't exist. That's one of those things that life needs. And you're going to learn what it means to be alive in this chapter. So that's why this chapter is relevant to everyday life. How about this? Who knows what this thing is? Right here on the left. What is that? A bird, indeed. But what kind of bird? I'm just kidding. I wouldn't expect you to know. I don't know what kind of bird it is. Anybody know what kind of bird that is? As far as I know, this might be fake. It could be like some kind of AI thing. But does anybody know what kind of bird that is? Okay. But you all agree it's a bird, right? All right, so that's part of life too. There's something called taxonomy where we classify different types of life, and you're going to learn about that in this semester. So even though you guys have, I assume, then never seen this particular bird, none of you knew what kind it was, but you all knew it was a bird, right? Because there were certain features about it, like the fact that it has feathers and a beak and those kind of feet, right? You're like, yeah, that's obviously a bird, even though you've never seen it. So that's one of the things you're going to learn about this semester. This one's a little bit more relevant to what we're doing in this chapter. This is hard to see, but can anybody tell what that person is doing at the bottom right?
Fixing the chain on the bike.
Yeah, he's fixing his bike. And what the old textbook was getting at is this person, this guy, is using the scientific method when he's doing this. And we're going to talk about the scientific method in this chapter, actually throughout the semester, but you're going to be introduced to it in this chapter. And the point is that I'm about to make a little bit later is that we use the scientific method regularly. You might not think it. You're not like, all right, step one of the scientific method is observation. You're not thinking about it. But as you go through your everyday life, you're very often using it. An informal version, but you're still using it. Sort of like math, right? A lot of times math, like you've never used algebra in your everyday life, depending on what your everyday life is, but you actually are in the background. You just don't know it. Anyway, any questions about this? As far as the exam is concerned, this is unimportant. We're just kind of introducing you to this course. All right. So why does biology matter to you? Again, these are other things that are not going to matter for the exam. But this is a good independent work topic. Also, I'll say this is the one time you can turn in a paper that doesn't require sources. Because here I'm asking you a question about you. You don't need sources for that. So you could write a short paper or a long paper, whatever. Write a paper, please. We get 20 points per page. And tell me why biology matters to you. Now, it could be a couple sentences. It could be a couple paragraphs. It could be a couple pages. Doesn't matter how short or long your paper is. Just turn something in. So one thing might be an interest in life, right? So if you're, if you're just interested in being alive and what keeps you alive, that's one thing, right? And these are just ideas. You don't need to write any of this down. The curiosity of the natural world, that's me. Like, I love to go on hikes. When I see things like a tree growing in a weird way, I'm like, I wonder what's causing that. Life is relevant and important to you, no matter your background or goals. Obviously, right? Because we're all alive. And biology, well, so that's what part of what makes it important. If you have pets, right? You might be interested in your pets. That's biology. If you're into fitness, like how many of you are college or student athletes? I figure we have a couple, right? A few, right? So student athletes, you have fitness, that's very much biology related. Gaining muscle, becoming faster, all those things that you might be concerned with your sports.
Question.
Yes.
Where do we turn this in?
Huh?
Where do we turn this in?
Turn this in?
Yeah. Paper?
Oh, yeah. So good question. So again, when you write papers to turn in for independent work, you're going to go use Google Docs. And if you don't know how to do that, see me after class, either online or in person. Go to Google Docs, write your paper, and when you're ready to turn it in, just hit the share button and share it with me. And again, if you forget that, meet with me online, and I'll show you how to do it. If you're into hiking, right, that's biology. If you're into gardening, that's biology. Then there's also stuff that people are really controversial sometimes. People debate GMOs. That's genetically modified organisms. That's biology. People have been debating vaccines a lot. That's biology. General health. You see a lot of misinformation, especially on social media about health. people trying to sell you a bunch of garbage. Like they talk about Big Pharma. And Big Pharma does have its issues, but like Big Pharma's trying to rip you off. Let me sell you this thing, right? It's funny how they do that. But anyway, we'll talk about that later. New diseases, right? Like COVID, when that came up, that was new. Bird flu is not new, but it might be up and coming. Things like that. Anyway, yeah, and again, that last little point is the stuff that people like to argue about. Climate change, people argue about the difference between gender and sex, two different things. So anyway, yeah, this is just some stuff to think about. And again, if you want to write a paper, tell me why biology matters to you, go for it. And again, I highly recommend at least writing one paper this week. It's trial and error. That's the best way for me to teach you how to write these papers is you turn something in and you say, that was good, but you should do this next time. Any questions about this slide? All right, let's finally jump into this chapter. This chapter is broken down into two main parts, which I see now are very hard to read. The first one is themes and concepts of biology. The second one is the process of science. So basically, this is like teaching you what biology is, what science is. And then after this chapter, we'll actually start getting into biology. So here, this is the learning objectives of this first portion. I know, again, it's hard to read. You need to be able to identify and describe the properties of life. You will need to be able to describe the levels of organization among living things. And you will be able to list examples of different subdisciplines in biology. As far as I'm concerned, and this is straight from your textbook, I'm going to put an X through that last objective. We will talk about it, but I'm not going to test you, I don't think. I don't plan on testing you much about the subdisciplines of biology, like zoology and mycology and ichthyology. We'll talk about it, but it's not very relevant. So, who knows how to define biology? Or what's your, when you grew up, what was the definition of biology that you've always heard or used? Anybody?
Plants.
Plants does involve biology, true. But if someone said, if some kindergarten said to you, hey, I know you're in college, what's the definition of biology? Study of life.
Yeah, study the
Study of life, good. I think so far that's the best one, is the study of life, because that is what biology is. We study life. But your textbook defines it as this: the science that studies life. And I like that so much better. And I'm not, whoever said study of life, I'm not downing you, because that's what I grew up learning too. But I like that definition better. Biology is the science that studies life. Or you could also call it the scientific study of life, right? Either way, it's saying the same thing in a different way. And the reason I like this better is because we're not just studying life, but we're doing it scientifically, right? So biology, now that you know the definition, and I'm going to check mark next to this because you do need to know that definition for the exam. Biology is the science that studies life, or the scientific study of life. So then that brings up new questions then. All right, then what does it mean to be alive? What is life, right? How else can you study life, right? So if we're saying this is the scientific study of life, what are the other studies of life? And then finally, if we're saying biology is the scientific study of life, then what is the scientific study, right? So this is the kind of things we're about to answer. So here we go. First of all, let's talk about what life is. There is no definition. Well, actually, let me back up before we do that. Another good independent work topic. I'm going to be trying to give you independent work topics throughout the semester and the lectures. So I just told you that the book definition is the biology. Biology is the science that studies life. One paper you could do, and you can do this throughout the semester, this is a really good independent work topic, is take something that I've told you, like something from the textbook, and then look up another source and compare and contrast. Right? So your paper, in this case, would say, according to the textbook, biology is a science that studies life. According to this source, biology is, right? And then provide that definition, right? So you have two sources there, your textbook and some other source. And then write a sentence or two where you just compare and contrast. Like, here's how those definitions are the same, here's how they're different. Does that make sense? So for every information I give you, and I'll often forget to remind you, you can do that for independent work. For anything I tell you that you see in the textbook, look it up, right? One thing about a college education, in theory, is you should be able to think for yourself. So you don't trust me, don't take my word for it. Don't take your textbook's word for it. Look it up, right? Anything that you find interesting, look it up. Compare and contrast, see what other sources say. Anyway, back to what you will need to know for the exam. You will need to know the properties of life. So again, there is no definition, at least in this course, where we say the definition of life is, we don't have that. Instead, we have properties of life. We have like little things, little check boxes that things that are alive, they exhibit these characters. They exhibit these properties, and you need to know them. And I will tell you, there's I think 8 or 9 of them. Okay, 8. There you go. And again, depends on the source, right? So according to this textbook, there's 8. You do not need to memorize them necessarily. There's not going to be a question on the exam where I say list all 8 properties of life. But what you will get in this multiple choice exam is a question where I say, all right, here's a bunch of properties of life and one that's not a property of life. Which one does not belong in this list? Or vice versa. Here's a bunch of things that are not properties of life, but one that is. Which one of these things is not fit? Does that make sense? All right, so keep that in mind as you're studying the properties of life. So here we go. Here they are. We're going to talk about them individually. You can write them down if you want, but again, we're going to talk about them individually. The first one is order. Actually, I'm not going to list them because we're going to talk about them individually. So let's talk about the first one, order. This also should be like slash cellular, right? So that's the more important one, I think, right here. Order, it should be slash cellular, not sub bullet point. All life is cellular, right? If it doesn't have cells, it's not life. Or if it's not at least one cell, right? So all life is cellular. All life has order. So again, you need to know that if it's not a cell, it's not alive. Now that doesn't, we'll leave it at that for now. We'll get a little bit deeper into that later, but for now, that's okay. You also need to know that the cell is the basic unit of life. And yeah, that's pretty straightforward, right? The cell is the basic unit of life. The cell can perform all the activities required for life. That's what makes it alive, is it can live technically on its own. You know, some cells, especially with multicellular organisms, require other cells to help them. But in theory, a cell can perform all the activities required for life. And the 2 bullet points above this are not in your textbook, but you need to know it. So take note of that for sure. So the information I just gave you is not in your textbook, but I require you to know it. Very rarely do I do that. It's 100 level class. I usually like to teach out of the textbook, but there are some occasions when I don't, and that's one of those occasions. So again, life is ordered, meaning there's levels of organization, and we'll discuss that soon. So as far as I'm concerned, for this property of life, what you need to know is that life is cellular. The next word for attendance is frog. As you can see right there, there's a frog. So again, if you're in person, you can send me those words after sometime before 9 a.m. and get extra credit. If you are online, you must send those words to get your regular extra credit and to be counted as present. And a reminder to anybody who's come in late since we started, you have to send me an email just to let me know that you're here. Otherwise, I won't know you were here, and you'll be counted as absent. Make sure you send those emails. And try to be on time. All right, so any questions about order? All right, the next one is sensitivity or response to stimuli. So for example, plants, like this particular one, even though you can't see it because it's just a picture, you can't see it in action. But if you were to touch that leaf, it would like crinkle in, right? It would kind of like shrink back away from the touch. A lot of plants grow towards sunlight, right? That is a sensitivity or response to stimuli. Bacteria, right? Those are single-celled organisms. But if they're in like an aqueous solution and you put something in it that, wait, let me just read you the book example. Sorry. The book mentions something, I already talked about that. And yeah, anyway. So if you were to put something toxic in the same water or the little petri dish or whatever, wherever the bacteria is, it will avoid it, right? It will move away from it. And it's not like bacteria have brain, they're not thinking, but that's just one of the properties of life. Life responds to stimuli. What do you think would happen to you guys right now if I were to turn the heater up to 105 degrees in here, Fahrenheit? What would you do? Your bodies, what would they do, you think?
Heat up.
Yeah, they heat up, you probably start sweating, right? That would be a response to stimuli. Some of you are already doing this right now. What's your name again? Gold. Poor guy, he's squinting because the sun is shining in his eyes. That's a response to stimuli. Right? His pupils are getting smaller because of it. That's a response to stimuli. Any questions about that? Pretty simple, right? The next one's also really simple. Reproduction. Life reproduces on its own. So you need to know that. And that's actually a pretty big one because things like viruses, as you're going to learn later in the semester, viruses are not considered to be alive because they cannot reproduce. They have to hijack our living cells to reproduce. But yeah, reproduction, right? Life reproduces itself. There's two different types, asexual and sexual. So I'm going to put an X through that, even though you both talked about it in chapter 1. I'm putting an X through it, indicating that I will not be bringing that up in the exam, because we're going to talk about that later in the semester. But for now, just know that the ability to reproduce is a property of life. Also, let me back up really quickly too, because I forgot about this. But again, to be considered alive, something has to check all these marks, right? They have to have all the properties of life, not just some of them. Because a lot of things that I've been teaching you so far, and that I'm about to teach you, non-living things have. Of course, non-living things aren't cellular, so that's not a good example. But there are levels of organization for non-living things, and we'll talk about that when we get there. Sensitivity or response to stimuli, non-living things do that, right? If it gets too cold, the heater's going to kick on because we have a thermostat in this room. Excuse me. That thermostat is going to respond to the dropping temperatures, right? So that's a property of life that a non-living thing has. Reproduction, though, again, that's one of those hard ones. Now, maybe one day, probably not too far from now, I bet AI will be able to design and manufacture, and make machines that make other machines. So maybe one day, some non-living things will be able to reproduce. But for now, that is strictly for living things. Any questions about reproduction? All right, the next one is adaptation. Living things are adapted to their environment. They're fit for their environment. This is why whales, which are mammals, have flippers instead of legs, right? They're adapted to live in that aquatic environment so they can swim. That adaptation enhances the reproductive success, which is something we're going to talk about later in the semester, so I'll put an X through that because I'm not going to ask you that yet. Adaptation arises via natural selection. We'll definitely talk about that later in the semester, but I'm going to put a question mark next to that because I'm not quite sure if I'm going to ask you that on the first exam. Again, like it says right there, we're going to discuss this in greater detail later in the semester. But for sure, for this first chapter, for exam 1, you're going to need to know that adaptation is one of the properties of life. And it just refers to their fit to their environment. And if you download the PowerPoint, you can click that little link right there, and it'll give you an example of something, adaptation versus natural selection. Later, that might get confusing. Right now, you don't even need to worry about it. But again, adaptation comes from natural selection. So sometimes people get the two confused. Like, what's the difference between adaptation and natural selection? For now, you can just kind of mush them together. But if you want to, you can click that and learn the differences between the two. All right, any questions about adaptation? But of course, there's a picture of a giraffe. Does anybody know what the adaptation is for the giraffe? There's a lot of them, but the big one, what's the big adaptation for a giraffe? If you get the what? Spots, that's a good one. That's not what I was thinking of, but yeah, spots. What do you think the spots are for? How is that a fit for the environment?
Camouflage.
Camouflage, right? So it can hunt?
No.
So it can avoid getting eaten, right? So it can avoid being hunted. What's another big one for the giraffe? The long neck, right? Yeah. What do you think that's, how does that make it fit for its environment? You might know, not that you need to know. I'm just curious to see. What is it? To eat, yeah. So it's with that long neck, it can eat stuff that other herbivores can't eat, right? So it gives it a food source. Anyway, that's adaptation. Here's the next one. Growth and development. Very simple, right? Living things grow when they develop. Even a single-celled organism, that one cell, it will get a little bit bigger. That one cell will develop. Now, granted, it's not developing like we are, or like those little kittens, those little invasive species over there. But every living thing grows and develops. And we're going to have a whole exam about growth and development. For now, you just need to know that that is one of the properties of life. So yes, the instructions on how to grow and develop are encoded in your genes, but we'll talk about that later. I'm putting an X to it, indicating it, but I'm not going to ask you about it for the first exam. Any questions about growth and development? All right, this one I don't really like. To me, this isn't different enough than one of the previous ones I already taught you. Response to stimuli was one I already taught you. Now, technically, this is technically different if you split hairs. This one is regulation / homeostasis. Homeostasis means steady state. I'm probably not gonna ask you that. But the point is, life maintains a steady state. Like, who knows what your temperature is supposed to be in Fahrenheit? What's the average human temperature in Fahrenheit?
98.
Yeah, 98.6, right? And most humans keep that, no matter what, right? You put them in hot weather, they stay 98.6. You put them in cold weather, they stay at 98.6. That varies a little bit, but generally, we have things, our bodies regulate it to keep it that. Does anybody know what your blood pH is? Not that you need to know any of these are all just examples. All right, your blood pH should be about 7.4. If it varies too much, you die, right? So how many of you ever had a margarita? That's a lot of acid, right? There's a lot of acid inside that lime juice. And yet you didn't die, right? Because your body maintains that pH of 7.4. So life maintains a steady state. And then there's some examples, as you can see from this PowerPoint. pH, we had to talk about, like, for example, blood pH, your temperature, chemical concentrations. That'll make a lot more sense later, because your body needs a certain amount of glucose, for example, and it has a way of keeping a certain amount of glucose in your cells. But again, we'll talk about that later. Actually, I should have put X marks next to that. Check marks. Let me put a big X to there. Because again, those are examples. I'm not necessarily going to test you on those examples. But yeah. And again, another thing, sort of like stimuli. Some living things also regulate, right? Again, if you have a computer out, right? If you run it too long, it gets hot, what happens? Fan kicks on, right? Because it's trying to maintain a certain temperature. It's trying to stay within a certain temperature range, right? So even non-living things do this. But again, to be alive, you have to check all these check marks. The next one, this is a big one. You're going to have a whole exam on this. Energy processing. So all life processes energy. First of all life needs energy. Without energy, there would be no life. But it also has to be converted from one form to another. Like, where did you guys get your energy? You're here you are alive and awake today. Let's just focus on alive, not the awake part. Where did you get the energy to be alive right now? Anybody know? I'm kind of leaving that vague because now there's a few ways you can answer that. Where did you get the energy? Why are you alive right now? Where'd that energy come from? Sleep, I like that. And that would be a different discussion that we won't even talk about in this semester. But yeah, because without sleep, you're tired, right? But it's even deeper than that.
Food I ate yesterday.
The food you ate, yeah. You got your energy from the food. The energy in you right now that keeps you alive came from the food you ate. And that's it. That's exactly where it came from. And that energy ultimately came from the sun. So all the energy in you right now that's keeping you alive ultimately started from the sun. There are a few exceptions that we'll talk about later, but generally speaking, all the energy that's keeping you alive came from the sun. And when you need energy, like he said, you have to eat. You can't just go outside and be naked and absorb the sun, right? The sun energy doesn't work that way, not for you anyway. So you have to eat things to get your energy. Even though it came from the sun, you still had to eat something. And when you ate that thing, you converted it. We're going to talk about those conversions later in the semester. And once again, I'll say too, non-living things also process energy. This is running on, I guess, AC power, maybe DC. It might be running on DC electricity, but it's plugged into this wall, which has AC electricity, so it had to be converted from AC to DC. And that came from John Amos, right? And John Amos took coal and burned it, and coal is a chemical energy. And when it burnt, it released heat energy, and that created steam, and then steam turned turbines. Now we have mechanical energy, and that mechanical energy was converted into electricity, right? So even non-living things have this energy processing. Also, by the way, even that non-living thing, that energy that I just described, ultimately came from the sun, right? The sun made plants way back millions of years ago. Those plants died, decomposed, became coal. Humans burnt them, released that energy, right? So again, ultimately that energy came from the sun. Any questions about energy processing? And again, we'll have a whole exam on that. All right. The next one is evolution. Life evolves. And I might ask you this, I'm not sure yet. Again, you'll have a whole exam based strictly devoted to evolution. But what is evolution? It is how populations change over time. And the question mark indicates I'm not sure if I'm going to ask you that on the first exam. But yeah, that's what evolution is how populations change over time. People misuse evolution a lot. like in everyday usage of the word. Like, oh, I've evolved since the last time we've seen each other. Now, you haven't evolved. People don't evolve. Individuals do not evolve by the strict definition of the word evolution. Only populations evolve. You might change, but your change is not categorized as evolution. We'll talk about that later in the semester. Natural selection and evolution, they do go hand in hand, but they don't mean the same thing. Natural selection is just one of the ways that populations evolve. Definitely don't need to know that yet. You will later. Evolution does not always result in a new species. We'll talk about that later too. So a lot of times when people say they don't believe in evolution, that's usually what they mean. What they usually mean is they don't believe that new species have arisen from evolution. And that's a whole different story. And as you'll learn when we get into this chapter later, you see things evolving. I will give you examples of things that are evolving right now because they don't always end up in a new species. Anyway, are there any questions so far about evolution? All right. Let's see. So here we have a bunch of animals. So the next word for attendance, pay attention here, I'm changing it up a little bit. The next word for attendance is going to be your favorite type of animal. So everybody's going to have presumably a different answer. Don't overthink it. Like, I'm not going to follow up on it. If you think, I don't know, do I like dogs or cats more? I don't care. Just write something down. So, if there are no questions about that, then we are done talking about the properties of life. Are there any questions about the properties of life? So again, I'll remind you for the exam, you're going to need to be able to pick one of these things does not belong, right? So I'll give you a list of properties of life, and one of them is not a property of life, and you need to check, you need to recognize that. Or vice versa. I give you a list of things that are not properties of life and one that is, and you need to choose the one that is. Also, there's probably going to be a question where it's like a scenario, like, hey, I found this thing in a laboratory. I don't know if it's alive or not, and I describe it. And I give you a bunch of things to describe it. And maybe one of those things that I described is a property of life, or maybe one of them is not a property of life. And you need to recognize it, like, oh yeah, that's the property of life. So again, when you study, I'm not going to ask you to spout out all 8 properties of life, but you need to be able to recognize them in a list or a scenario. Yes, ma'am.
So, could you explain when we having quizzes, are they always online and when is our first test?
Yeah, good question. So quizzes are online. They are due every 2 weeks. So not this Sunday, but next Sunday, your first quiz is due.
By that Sunday?
Yeah, good question. And they should all be open. You should be able to start them whenever you want. And to remind you, you can take them as many times as you want. So it wouldn't hurt you today when we're done with lecture for you to go and try the first quiz. You might, I would assume, if you don't know a lot about biology and this is like your first introduction to it, I would assume you'll fail it the first time. But that's okay. Just keep, then after the next lecture, go back and take it again. And just keep taking it, right, until you get the full 20 points. And then if I were you, even after you get the full 20 points, then keep taking it, retaking it, because that'll help you prepare for the exam. Good question.
And then you said the first exam is when?
The first exam should be in a month. It should be every 4 weeks. But that's a little bit flexible.
Okay.
So if we're way ahead of schedule, I might pull the exam a little bit earlier. If we're way behind schedule, I'll definitely push it back. I'm definitely not going to test you on something you haven't. Yeah. So any questions about the properties of life? All right, the next thing you need to know about is the levels of organization. And this is another good, so again, let me back up one more step, sorry. Again, a lot of these properties of life, like I was kind of hinting at, that's basically what you're going to learn about in this exam, or this semester, right? It's like growth and development. You're going to learn about that. You're going to learn about reproduction. You're going to learn about energy processing. You're going to learn about evolution. All these things that make things alive, that's what you're going to learn about. The bad news is, like, you need to know this to understand life, but the bad news is, admittedly, even though I love biology, a lot of this is the boring stuff. This is why I have independent work, right? Like, so if you're into like Shark Week, you can research about sharks. I'm not going to teach anything cool like that. I'm teaching you the basics. All these properties of life, that's what you're going to learn about. You're going to learn about what makes you alive, which will then help you understand more important, or not more important, but more entertaining things. Anyway, so that's the properties of life. Another good way of looking at the entire semester is this right here too. The levels of organization of living things. And you do need to know this. Much like the properties of life, you don't need to, I'm not going to ask you to dot them all off in one question where they list all the levels of organization in the correct order. I'm not going to do that. But much like the properties of life, you might have a question where I like list a bunch of things that are not levels of organization, and you have to choose which one it is, or vice versa. Or more likely, unlike the properties of life, you need to know this in order. So more than likely, the question you might get about this will put something like, all right, here's a list of the organizations of life in order, and one of them will be out of order, and you have to choose which one, pick the one that's out of order. Something like that. So again, no pressure. It looks like it's a lot to memorize, but once again, I'm not going to ask you to list all of these in order. It'll be a multiple choice exam where I tell you, or you choose the one, which one of these is incorrect, right? A bunch of them that are in order, one of them not in order, you choose it. Make sense? All right, and again, this is a lot of how our semester is going to go. First, let's see, chapter 2, we're going to learn about this stuff. That's chapter 2. And then what? I think it's chapter 4. And again, I'm still working on this new textbook. So I'm not sure about the chapter, but the next chapter we learn after chemistry, we're going to learn about how cells work, right? Let's just call it chapter 3, I don't know for sure. We are going to skip tissues, organs, and organisms. But then we'll jump into learning about populations and communities and ecosystems and biosphere. This will all be like the last exam. F for final. So yeah, this is how the semester is going to go, right? We're going to start very small. We're going to learn about small things, and we're going to get bigger and bigger and bigger. So before we start talking about each one of these individual bullet points, I just want to again remind you, you need to know these in order. Not because I'm going to ask you to list them in order, but if I give you a list and one of something is out of order, you should be able to recognize it, but yeah, that doesn't belong there. So any questions before we start talking about these individually? All right. The next word for attendance, even though that's an atom, the next word for attendance, and again, the answer will vary depending on who you are. Write down a famous atom. So somebody who's famous, whose first name is Adam, or last name Adams, whichever. So a famous person with Adam in their name. Fictional or real, it doesn't matter. Fiction, nonfiction, I don't care. Anyway, so this is the first level of organization, an atom. An atom is the basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged electrons. For now, all you need to know is that the atom is the first step, right? The atom is the first level of organization. Next chapter, we're going to learn about atoms. Next chapter, you're going to need to know everything that's in this box, which means for the exam, you will need to know everything that's in this box. But for chapter 1, I just want to introduce you to what an atom is, and that's what an atom is. So just like the cell is the basic unit of life, an atom is the basic unit of matter. And you might be like, well, what is matter? Well, it doesn't matter what matter is for the first chapter, because we'll talk about what matter is in the next chapter. And then it'll matter what matter is. All right, so any questions about atoms? And again, I know I just showed you the list, but I'm just curious to see who memorized it already or who might know the next one. Does anybody remember what the next step is up from an atom? What happens when you put a bunch of atoms together? Or sometimes only two. Yeah. Next is molecule. So when you put atoms together, you get molecules. In this particular, I'm going to put it next to that. The example they gave was a phospholipid, but not all molecules are phospholipids. There's all kinds of different molecules. Phospholipid happens to be one of them that you're going to learn about later. But yeah, basically, as far as you're concerned, for chapter 1, when you put atoms together, you get molecules. We'll talk more about that next chapter. So, what happens if you put a bunch of molecules together in biology? Does anybody remember that? And again, I don't expect you to. I'm just curious to see if anybody knows. Yep. You put a bunch of them together, you get organelles. Organelles are basically the parts of a cell. There's different parts, they do different things. You're going to learn about it in not next chapter, but the chapter after that. You're going to learn about the different parts of a cell, what they do, what they're made of, like what kind of molecules they're made of, so on and so forth. But for now, again, since this is chapter 1, just leave it at that. Again, you put a bunch of atoms together, you get molecules. Put a bunch of molecules together, you get organelles. And I've already hinted at this, but what happens when you put a bunch of organelles together? What do you get? She said it, and then probably no one else heard it. Maybe anybody else know? If you put a bunch of organelles together, what do you get?
Cells.
Cells, very good, yes. So that's the next level, cells.
I do have a question.
Yes.
You want the definition in the box?
No, nah, good question.
Can you go back for like 2 seconds?
Yeah, so you do not need to know these definitions in the box.
Oh, I know.
And that was her question. So no, you don't need to know the definitions.
I just didn't know one you prefer. You prefer the definition on the page or inside this box?
Oh, right. Generally speaking, I'm not gonna ask you any of the definitions of these words. Like, you need to know what they are when I use them, but I'm not gonna test you on these words. Especially right now, because right now I'm just introducing you, so you know what level they're in, and I'm only providing an explanation, so it's not just a word. It doesn't help you if you know that organelles come after molecules, but you don't know what an organelle is. Any other questions? I know somebody asked me to back up. Are we good? No, to move forward? Good. Thank you. So again, yes, but put a bunch of organelles together, you get cells. What happens when you put a bunch of cells together? Does anybody know?
Tissue.
Good, you get tissue, which we're not gonna learn about this semester, this course. If you take anatomy and physiology, you learn about it, but this one, we're skipping. And again, that's tissue, like human skin tissue is an example. I'm not talking about like something you wipe your nose with. Though some people do use to wipe the nose with their skin. Don't do that, especially with bird flu coming around. Anyway, we put a bunch of tissues together, you get organs and organ systems. You put a bunch of organs and organ systems together, you find the respiratory system, the digestive system, you put all that together, what do you get? You get an organism. And an organism is just an individual, right? So you are an organism, I am an organism, he is an organism. Here's where it gets a little bit trickier, and you're definitely gonna need to know this later in the semester, but for now, I'm just gonna introduce you to it. If you put a bunch of organisms together that are the same species, that's called a population. So right now, this room is a population of humans. Right, we're all the same species, we're all at the same place at the same time, dealing with the same factors, right? Same temperature, and it's 8:50, we have to end. The last word for attendance is just come up with a question. So it's not a word at all. Come up with any question from any material that I presented today, and that's your last attendance word. Even if you think you know the answer, just write something down that shows that you listened to what I said. That's it. And I'll see you on Friday, unless you visit me for office hours. Excuse me. And don't forget, if you were late, please send me an email. This says you came in late. Better late than absent. And for those of you online, again, I'll remind you, make sure you send me that list of words and the question sometime before 9 a.m. And for those of you who are watching the video, as opposed to being, in person or streaming online, if you're watching the video, you need to send me those words and that question sometime before we meet on Friday. Otherwise, by Friday, it will be too late. At least for the points. You should still watch it because you need to know it for the exam. But as far as points are concerned, Friday is too late.